are nature's gifts and they serve many purposes. For some people, its shore serves as a place of relaxation during the warm summers. For others, it is a source of drinking water and food. To communities in the Northwest Territories, however, lakes provide additional importance because they are covered with ice for about 7 to 8 months of the year. This ice allows community members to build winter roads on them to move people and goods into areas that would otherwise be inaccessible. As we all know, high temperatures causes ice to melt. This is the same for lake ice, which is reducing drastically due to the changing climate and increasing temperatures. In view of this, it is important to monitor the thickness of ice on these lakes when they begin to melt and which areas of the lakes are safe for the construction of these winter roads. But in many cases, deriving this information is challenging due to several reasons. Firstly, since lake ice is a subsurface feature, it requires processes like drilling to measure thickness accurately. This, in addition to adverse weather conditions, is a limitation when collecting data. Secondly, there is the difficulty in measuring several locations on the entire surface of the lake on a regular basis. And lastly, other sources such as satellite images cannot effectively estimate ice thickness because it is formed below the surface. My research seeks to address these challenges by adopting a multi-method approach for the estimation of ice thickness. I utilize remote sensing data coupled with a numerical model to estimate the daily thickness of ice on small lakes in the Northwest Territories. Currently, the model is one-dimensional, which means it estimates ice thickness for only a single location on the lake. My research, however, will transform this model by spatially distributing it to allow for the estimation of the entire lake as opposed to a single point. Achieving this would enable us detect all the areas of the lake which are safe for the construction of winter roads and the areas which are not. I intend to estimate the ice thickness on all these lakes from the year 2000 to present, just to allow me to determine the trends and factors influencing this. This research is important because it informs the community on when lakes are safe for winter travel and which areas are the safest. In addition, different factors affecting the formation and processes of ice can be actively monitored and managed. Lastly, results from this study will support decision-making, planning, as well as vulnerability and risk assessment for surrounding communities. With this, I say, let's make lakes safe for winter travel. Thank you.